Phrases you don't hear in classrooms very often, but thank you. My favorite student, good old Anne. She gets everything right. She hasn't made a mistake in a long time. So, whenever you ask me to write a name, the first thing I ask myself before I do anything else is this ionic or covalent? Next year, you'll be doing both. There are different rules for naming covalent compounds. This year, we're only going to be doing ionic, but I want to build that habit into you already. Whenever they give me a formula, compound, or a name, is this ionic or covalent, Quentin? That's the first thing I ask. Then, if it's a formula, which they gave me, and it's ionic, I ask, is this multivalent? In other words, I already mentally put a little star in my mind next to that one. It's going to be a bit trickier. I already mentally put a star in my mind next to, I think cobalt is multivalent, isn't it? Yeah. And I put a star in my mind next to that one. It's going to be trickier. Is Na multivalent? No. Then it's just going to be sodium, 1 mark. Chloride, 1 mark. So you'll get 1 mark for that, 1 mark for that. And then how many atoms are there in this molecule? 2. That gets you 1 mark. So that's how each row is going to be out of 3. That's where you're giving the name, and you're then being asked to, given the formula and being asked to give the name. Or I'll give you the name and ask you to do the formula. It's a bit trickier. So calcium bromide, I have to do some rough work. I'm going to do that right here. I'm going to write calcium, which is 2 plus, bromine, which is 1 minus. Now I bring out the crisscross. Do you get CaBr2? Yep. So 1 mark for the Ca with the correct subscript. You could put a 1. Nobody does. 1 mark for the Br2. And then how many atoms are there in that molecule? 1 mark for that. So those are the 2 types of questions in this chart. If you're wondering, how do you get 3 marks? Okay. FeCl2. This one is much tougher because iron is multivalent. I have to work my way backwards. I know that Cl is -1. How many Cl's do I have in this molecule? 2. So I have a total of 2 negatives. That means I have to have a total of 2 positives. How many Fe's do I have? Just 1. That means that one has to be the 2 positives. So it's going to be iron, good gosh. Iron 2 chloride. 1 mark for the iron 2, all or nothing. 1 mark for the chloride. If you missed the Roman numeral, no dice. And this molecule has 3 atoms. I find for multivalent, if they give me the name, it's easier to get the formula. Because copper 1, they've just told me it has to be a 1. Sulfide, is sulfide 3 minus, or I'm going from memory? 2 minus. My brain was telling me that was wonky. So I crisscross, and I'll get Cu2S, is that correct? 1 mark for the Cu2, all or nothing. 1 mark for the S, all or nothing. And then this also has 3. Now we get into the polyatomic ions. Calcium, is it multivalent? No. So it's going to be calcium. What do I call OH? 1 mark for calcium, 1 mark for hydroxide. Ooh, this is trickier. How many atoms? I'm going to do a little rough work. 1 calcium. There's 2 inside there, but there's 2 of those 2. That makes a total of 4. Is the answer 5?
Yep.
Okay. And you can see we're sort of bringing some of the math that you're currently learning in Math 9, where you're getting rid of brackets and doing distribution or front door bomber, or whatever your teacher calls that thing. It's kind of the same. Potassium permanganate. Potassium is K+. I have no idea what permanganate is. MnO4-? This is a nice match made in heaven. It's a 1 and a 1. This crisscrosses wonderfully. So the formula is going to be KMnO4. You could put the MnO4 in brackets. It's not required in this case because how many MnO4s are there? 1, so the brackets are redundant. How many atoms? 1K, 1 Mn, 4 O's, 6. Again, 1 mark for the K, 1 mark for the MnO4, 1 mark for the 6. Okay. This one's going to be tricky. Cr2O7. Cr2O7 is a 2 minus. How many Cr2O7s are there grand total in this molecule? 3. So, Gabe, I'm going to argue grand total, I have 6 minuses. 2 minus, 2 minus, 2 minus. How many pluses do I have to have? 6 pluses. Gabe, how many cobalts do I have in this molecule? What does each one have to be so I get 6 pluses? So it's going to be cobalt 3. What the heck is Cr? I didn't even dichromate. 1 mark for the cobalt 3. If you missed the 3, sorry, you don't get that mark. 1 mark for the dichromate. Ooh, boy. I'm going to have to show some rough work here. There's 2 cobalts. Inside the brackets, there are 2 plus 7, 9, and there's 3 of those. Is it 29? Okay. Oh, and use bed mass also as part of this, right? You sort of treat the you treat the brackets as brackets. Manganese 3 phosphate, not phosphide, not phosphite, phosphate. Phosphate is PO43 negative. Manganese is Mn, and then it says to have 3 plus. When I crisscross, I'll get 3 and 3. Will I leave it as 3 and 3? What will it become? 1 and 1. Will I bother writing the ones? No. So it's going to be Mn1, PO4, 1. Which I'm not going to bother writing. And Mara, that's what now. So 1 mark for Mn, no subscript. 1 mark for PO4, no subscript. Now I'm going to write the number of atoms. Mn, 1. P, 1. How many O's? So I got 1 plus 1 plus 4. 6? Sloppy mistake, do your correction, you can get the mark later. But honestly, Jimmy, be mad at yourself and don't make that mistake again, right? You don't want to do it on a test when it counts. MO2 CRO, okay, what the heck is CRO4? That's not dichromate, that's just chromate. And it has a 2 negative. Okay. So, one of these is 2 negative. I got 3 of them. So I got 6 negatives. How many I have to have 6 positives. How many molybdenums? I can't even say it. Do I have 2? That has to give me 6 positives. Gabe, what's going to be the charge on each molybdenum? All right, I got to spell that one right. Molybdenum. I won't take marks off, but molybdenum 3 chromate. How many atoms? That's a great question. 2 molybdenums. Inside the brackets, I have 5 and 3 of those. So 17?
Yeah.
There you go. Ammonium. This is the only positive polyatomic ion that we'll be using this year. There are others, but this is a common one. So ammonium, I know, is NH4 plus. Isn't it? Scared me for a second there. Phosphite. Is that phosphite or phosphide? Phosphite. That's on the back. And again, I've gone on my rant about how stupid the naming is. I can't change that. PO3, 3 negative. So when I crisscross, I'm going to need 3 NH4s, 1 PO3. Is that right? So 1 mark for having NH4 in brackets with a 3, 1 mark for having a PO3 all by itself. Now, how many atoms are there? This one's trickier. It's going to be 5 times 3 plus 1 plus 3. Is that right? 15 in the first group, and then a phosphate, phosphorus, and an oxygen. 19? Can you give yourself a lovely score out of 30, please? If you need to lawyer with me, now is the time. Last day, then, we did more practice with ionic compounds. This one I did attach an answer key for. And then we talked about writing ionic compounds. This one I didn't have an answer key for, but I put an answer key online. We're going to pause for a second with the writing and the naming. We're going to see if we can finish off most of chemistry today. Right now, I'm thinking your test is going to be probably towards the end of next week, because I want to give you lots of practice and review, because this will be the big test leading into Christmas. Okay? And then you may notice I haven't done any labs with you yet, and that's because most of the ones in the textbook are weak. Just before Christmas, we are going to do a lab where I promise you we're going to blow something up. Not a big explosion, Jimmy. Don't get your eyes too big. But each of you will be separating hydrogen from another compound, capturing the hydrogen, and then sticking a match into the hydrogen to see what happens. And I'll give you a hint. Cool stuff. So, you learned in Science 8, and we reviewed at the beginning of this year, what we called KMT, which was an abbreviation for Kinetic Molecular Theory. I'll do it in darker colors so you can read it easier. So, Kinetic Molecular Theory, what did it say? It said that all particles are moving. They are closer together in a solid. They are further apart in a liquid and moving faster. They are further apart in a gas and moving faster. What was the phase change that you just saw in the little heat pads that I gave you? We went from a liquid to a... What happened to the particles? What happened to their speed? Okay, I'm going to phrase things in a physicsy way. Here's what we would say. When they slowed down, they lost kinetic energy. And that energy has to go somewhere. Where did that energy get transformed into? What did you all notice? What type of energy? Huh? Heat. It's a conservation of energy, physical change. Now, once these completely cool off in about an hour or so, I put them in some boiling water, I reboil them, and they turn back into a liquid. What I really do is I add that heat energy that they lost back to the system. I get the molecules moving fast again. And then once I let them cool to room temperature, because it's a sealed device and very, very pure, they'll super freeze again. I can get them to below their freezing temperature. Now, when you snap that little piece of metal, what actually happened was a few molecules of that metal flaked off, and that was the initial impurity that you needed to get the first, I'll call it ice, I know it's hot, but the first solid crystal to form, and then you saw the physical reaction, the phase change go all the way through. Yeah? Because the molecules are slowing down, which means the molecules are losing energy, losing kinetic energy, and Connor, who's in Physics 12, is learning about the law of conservation of energy. We phrase it that way because it's one of the fundamental laws of the universe. It basically says energy can't vanish, it's got to go somewhere. So if they slow down, that energy's got to go somewhere, it goes into heat. Similar reason, by the way, for example, when you're skidding with your bike tire, you're losing energy, and often you'll see your bike tire gets hot, but it's got to go. The energy's got to go somewhere. Okay. Chemical bonds are how atoms are held together. What we're going to be talking about today, Sarah, is the difference between physical changes and chemical changes. Unfortunately, like everything else that I'm teaching you, I'm going to give you a rule that's only a mostly rule, that there are exceptions to this rule every time, but I'll give you a rule and then I'll say, I promise you the questions that I ask you will work with the rule that I'm going to give you, even though there are exceptions to the rule that I'm going to give you. So physical and chemical changes, put your pencils down, look up. So hell yeah, I tried something different. This time I gave you the lesson in video form, and now we're going to fill in the notes and see if we can get this right. So, in physical change, bonds are not broken. Oh, bonds are not broken. Thank you. I was going, why did I put 2 spaces for 3 words? 2 spaces for 2 words. So the particles are still the same, but the size or the shape of the object has changed, or the physical state from liquid to solid to gas to plasma or whatever. They often involve an energy change. Certainly when you're going from one state to another. To melt something, you add heat. To freeze something, you take heat away. Words to describe physical changes: tear, cut, boil, dissolve. Can you give me some words that you think might also be physical changes that I would use in a description? Break, melt. What else? Freeze. What else? Let's go. How about rip? Let's be violent. Rip, chop, cut.
Burn.
Yeah, so a lot of your cooking instructions before cooking, okay? Slice, chop, mince, all those, because you still have onion if it's an onion, you still have potatoes if it's whatever it is that you're applying the knife skills to. Here's some of the other ones that I came up with as well: ripping, cutting, grinding, tearing, melting. And then I said, actually, all of those from that chart way back on page 21 from the first test that we wrote, those are all physical changes. Okay? I'm not going to ask you to recreate this chart on the test, but I certainly will use these words again. And you'll have to realize, oh, that's a change in state. That's a physical change. What about chemical changes? In a chemical change, chemical bonds are broken and then reformed with different atoms. Here is the key one that always works. Something new is produced. If something new is produced, that's a chemical change. And it is almost always non-reversible. There are a few obscure exceptions, but I won't give you any that are that obscure exception. So you can say, is it reversible? No, that probably means it's a chemical change, although ripping a piece of paper in half is also not reversible. That's a physical change. Was something new produced? Yes. So what we're going to teach you is some of the signs that you can look for to see if something new is produced. Words to describe physical change. These are 2 that you can take to the bank. Whenever you... chemical change. I said physical. Chemical change. Whenever you burn something, that's a chemical change. When objects rust, that's a chemical change. Combine? Any others? Okay. Lots of cooking / baking words. Fry, saute, bake, etc. So most of those are non-reversible. Fruit, when it ripens, that's a chemical change. It's combining usually with oxygen in the air and forming new molecules. And then I'm going to give you some sciencey words that you can add to this list. So here are some more words. React. That's a chemical reaction. Oxidize, which is the fancy word for burn. Precipitate. And combine, someone already said. So on your test, in your homework, they will give you a situation and they will say, hey, is this chemical or is this physical? the one question that you can take to the bank 99.9% of the time, if you are trying to decide if a change is physical or chemical, ask yourself this question: was something new produced? Question mark. Was something new produced? If the answer is yeah, that's a chemical change. If the answer is no, then it was a physical change. So yes, chemical change. No, physical change. Clues that indicate a chemical change. These are worth putting a little star next to. So clues that indicate a chemical change. Number one, new solids form. You're mixing two liquids together, and when you shake them up, all of a sudden you see some solids gathering on the bottom. Probably that means that chemicals are combined in a different way, and we have a fancy schmancy word for that. The fancy word for a new solid that is formed from liquids in a chemical reaction is a precipitate. I think I can make that a bit bigger. There. Another way, another sign, another thing you can look for a chemical change, bubbling. Because this shows that some kind of gas is forming that wasn't there before, which usually means that some molecules are changing, and one of those molecules that's changing or being recombined is in a gaseous form. The only exception to that is when you boil water or when you boil something. So when you boil something, it bubbles as well. That's not the bubbling we're talking about. We're talking about you mix two objects together, Allie, and suddenly you see bubbles. You see a color change. If you see an energy change, that energy change usually means that there's a chemical change, but not always, because the one that I've given you has an energy change, and that's a physical change. If you see sound or light given off, that usually means it's a chemical change. Okay. Really? There can be sound? Yeah. If heat is given off, that usually means it's a chemical change, but the physical reaction that you're all playing with still, that gave off heat. That was not a chemical change. We have a fancy schmancy word for heat given off. The word that we use is exothermic. What's the other one? Do you see that in grade 8? Or did you just know the word? Now, thermal is the root word for heat. So really the tricky part is remembering exo or endo. So I always remember when heat is given off, when heat is exiting, it's exo. When heat is entering, it's endothermic. When heat is being absorbed. The entering doesn't quite work because it's END, not ENT, but close enough. And EX, exit, heat's being given off. Heat's leaving, heat's exiting. That's probably their two words that I might ask you to remember as vocabulary words on your test. Easy to get them mixed up, but I've given you a dumb way to remember them. Hopefully that'll work. Mr. Duke has a pretty cool example. You already have it. What type of change was this one? Physical or chemical? Your heat packs. Okay, physical. Why? Easily reversible. Reversible. And here is the key one. I'll even boldface and underline this. Nothing new was produced. Okay? Did you see any bubbles? No. Did you smell any odors? No. Did you hear any sound? No. Was there any light? No. There was heat, This is why I said not all the rules that I'm giving you work all the time, but that one that I just wrote in bold font, that's the rule that you can take to the bank. If nothing new was produced, it's a physical change, not a chemical change. Exothermic reactions, I studied them before they were cool. Okay.
Terrible.
What kind of bull? Terra? Okay. The jokes only get worse, Jimmy. A couple more terms. Vocabulary terms. So, when you mix products together, we call those the reactants. And then what you get out the other end in a chemical change are the products. You've sort of used these words without realizing it because you've talked or you've heard about, oh, it's a chemical reaction. You maybe even said that. The reason we call it a chemical reaction is you use reactants and then you get a product out the other end. When you're writing an equation, which is what we're going to get to eventually, reactants go on the left of the arrow. This is what you're putting in. Products on the right. And the arrow kind of means turns into or becomes, or if you want the fancy phrase, react to form. So CH4 and O2 react to form carbon dioxide and 2 water molecules. Did I say to copy down this in your notes? I think, do I have a space there? No?
Yeah,
You just
space.
But you just did I say to copy it down or are you just doing it because you're conscientious? We're going to learn how to translate that. In fact, we're going to learn how to write chemical equations and balance them and predict everything. It's not part of Science 9, but it's a huge part of Science 10. So I'll show it to you over the next few days. I won't put it on your test for Science 9. Maybe it's a bonus question. But I did this the last time I taught Science 9, and all of my kids the next year in Science 10 told me they were very grateful because it made Science 10 way easier. So we're going to sneak a little bit of Science 10 into Science 9. Would you like to see a video with dogs teaching chemistry?
Yeah.